nice. We continue forward, and now we're into translation. Right? So translation is where we change our language. We are going to go from nucleic acids to amino acids. And before we talk about how we're doing this, right, because we are now going to be doing this in the cytoplasm, and our site is the ribosome. Now we've got ourselves a little issue, and that is, how do we code for amino acids, right? We've got a sequence of nucleotides, right? How do we turn that sequence of nucleotides into nucleic acids, or from nucleic acids into amino acids? How do we code for amino acids, right? So that's pretty simple. If we look at our mRNA, what we will see is a sequence of nucleotides that can be divided up into sets of 3. Boop, 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 boop. So, what we have here is a set of 3 nucleotides that codes for 1 amino acid. And this is going to be called a codon, right? A set of 3 nucleotides, and they code for 1 amino acid. Now, there are more than 20 common amino acids in eukaryote protein construction. So, how do we code for all of these? Well, we have a whole bunch of different codons. And to be able to actually read these codons in an exam setting, you will be given a table, right? This is the codon table. And the codon table is pretty simple. All it is a table that shows you what a codon can be translated into. So if we look at our first codon that I put in here, AUG, we can simply look at our codon table and see A for our first letter. Here our second letter is U. So row, column, and then we just find our third letter in the codon, G, and that is methionine. You do not have to memorize likely that MET stands for methionine. I don't know if you're in my class or even at MSU Denver, but as far as I'm concerned, you don't have to know that MET stands for methionine. However, there are some very important things to know here in the codon table. One is that AUG does not just code for methionine. AUG is a start codon, right? Which means you start translation with an AUG. Translation starts with AUG. And if translation starts with something, that means that translation must stop with something. And there are 1, 2, 3 stop codons. You will notice that the start codon also codes for methionine, an amino acid. Stop codons do not code for amino acids. Stop codons do not code for amino acids. So, it is important to note that. It will become important later. So, these are the codons so that we know exactly what our amino acids will be, right? Not too terrible. So this is going to code for methionine. ACA is going to be threonine. CAC is going to be histidine. So THR, HIS, THR, HIS. Stop. And then we have, look what I did here. Look what I did here. Uh-oh. I put a T in mRNA. Ooh, common mistake. So then we have CAU and GAG. CAU, tyrosine, GAG, glutamine. So we can see that these will be the amino acids that this particular gene codes for. Not too terrible. Now, this brings us to an interesting question, because amino acids don't just bind directly to codons, right? Amino acids are bound to tRNA, right? So in the cytoplasm, tRNA carries amino acids. Which brings us to the issue of how does tRNA know which codon to recognize? And the answer to that will be our next teeny tiny biology bite on translation. Woo-hoo-hoo.